Hello everybody, I'm AM Solutions 101 and today I'll be going over Mechanics of Materials problem 2.26. So to get started, let me just read the problem for you. We have three-part axially loaded member that consists of a tubular segment with an outer and inner diameter, and we also have two solid circular segments at 2 and 3, one of them smaller than the other, and the line of action is down the center of all of them, and we need to determine the three axial stresses, sigma 1, sigma 2, and sigma 3, within each of the three respective segments. So the way I like to solve these problems is start off by just jotting down what we know. So here we know that we need to find the three stresses. We have a diagram here, showcases everything, and these are the inner and outer diameters of the segments, and those will come in handy much later when we're solving for the stress. So in order to find the forces within each of the members, we need to split the member in half. So this can be seen at force 3. So we have our two kips here, and I split it down the middle, which would be over here. And we have two kips coming out this way, so we need to have another force to balance it out going this way, and that would be another two kips force solved inside of there, and that's why F3 is two kips. And we can do the same thing for F2. So we split it down the middle here, and this one's interesting because you need to be careful. If you see this arrow, this two kips is acting on this end of the bar, and therefore it doesn't really apply to the center of it, but this three kips force will. So that's why I have it split down the middle there, and we have to, the internal force from 3 doesn't matter when we go to 2. So we split it down the middle, and we summate the forces here to find that we have a 5 kips force going in the opposite direction, and therefore it's a 5 kips internal force. And we can do the same thing with force 1, ignoring the force from the wall. We summate the forces here to find the internal force of F1, which is 2 kips in this direction, 3 kips in the right direction, and then 2 kips in the left direction. So 2 plus 3 minus 2 is 3 kips. So now we have our forces here that we just solved for, and we have the equation for stress, which is the internal force over the cross-sectional area of the member. So now just going ahead and solving by plugging in the forces, and also to be careful for that tubular segment. In order to find the area of that, it is the outer diameter squared minus the inner diameter squared times pi over 4. And that's how you would get the cross-sectional area, so that way you can solve for the stress. And those are our final stresses that we have solved for. I was too lazy to do all the algebra. And thank you. Please like, comment, and subscribe. And I hope this video helped you. Have a great day.